Well, thank you for joining me. I'm going to be looking at question 6, and this is the cost for production of X units of a certain product is given by 0.025 x squared plus 2x plus 1000. And use calculus to find the value of x for which the average cost per unit is a minimum, and use the second derivative to test to confirm a minimum and find this minimum average cost. Okay, well, let's get the derivative dx, dc dx, let it equal to 0 and solve that. That will optimize it. So dc dx would be 0.05 x plus 2. Right, if we let that equal to 0, we would say 0.05x equals negative 2. X is negative 2 over 0.05, which is negative 200 over 5. We've got to actually produce negative 40 units. Well, that's why, because there is a turning point when x is negative 40 on our parabola. If we were to sketch this, let's just do a rough sketch here. And the turning point is negative b over 2a, which is negative 40. So out here there is a turning point somewhere, and there is a y-intercept of 1000. So really what we've got is a quadratic, which is going to look like that. Therefore, the cost after we start producing at 0 items is just going to keep increasing. So the only minimum cost we've got is $1,000 by not producing anything. I think there must be. That's all we can do with this question, and if the textbook has a different answer, I think it's because they're operating on a different equation. But based on this question here, in the question, there is the graph, and the cost just keeps increasing. So the minimum cost happens when x is 0, and I don't think we want to produce none, because we're going to spend $1,000, and then as we produce, our cost is just going to increase and increase each time x gets larger anyway. So there is no, technically, there's no minimum average cost per unit, and no minimum value of x for which the average cost per unit is minimum. It's a difficult question, so I hope this has helped. Until next time, stay happy.